Good morning, everyone. Before starting today's session, let me ask you a very simple question. What is the difference between data, information, and knowledge? I'll pause for a minute for you all to think about it. So here I have given an example 12122012. What is that? It is just a set of symbols and characters. Coming to the next, I have mentioned date of birth is 12/12/2012. So what I have done here is I have integrated the set of symbols and characters with the context. So here the context is date of birth. Coming to the next, I have mentioned date of birth of person X is 12/12/2012. So what I have done here, I have linked the date of birth to a particular person. Now here, which is data, which is information, and which is knowledge? So the first one is data. Data is nothing but a set of symbols, characters, and observation which doesn't have independent meaning. Okay. Now next is information. When I integrate a context with data, it becomes information. So here I have mentioned date of birth is 12/12/2012. So I have integrated the context date of birth to the set of symbols and characters. So this becomes information. Now, what is the third one? Knowledge. So when I further process the information and link and store it, it becomes knowledge. I have linked the date of birth to a particular person X. Date of birth of X is 12/12/2012. Okay. Let me tell you another example. Assume that I'm conducting a scientific experiment. I got an observation 3. What is this 3? It's just a data, right? It's a numerical data. Now, if I tell length is 3 centimeter, that becomes information. And I'm attaching a context of length here. Okay, so I'm integrating context with data and that becomes information. Now, if suppose I'm telling length of the pencil is 3 centimeter, then I'm further processing the information, linking it to an object pencil, and that becomes more meaningful and it is knowledge. Okay, so we all know that nowadays there is an explosive growth of data. Data is being generated in terms of terabytes to petabytes. I have mentioned some sources of data over here. From business, you have a lot of data being generated in the web, in e-commerce aspects, transactions, stocks, etc. When we take science, we are conducting a lot of scientific simulations which generate data, remote sensing experiments generate data, etc. Now coming to the society, we are generating a lot of news articles. We are taking so many images. That's also a form of data. The videos which we are producing, that's also another form of data. So these are the major sources of data. Now, as a summary of it, we can tell that we are drowning in data but starving for knowledge. We are having a lot of data in hand, but we don't have meaningful data. Okay, so we are drowning in data but starving for knowledge. There comes the necessity of data mining. What do you mean by data mining? Knowledge discovery from data. We are trying to find meaningful information from raw data. So data mining can be formally defined as the extraction of interesting, non-trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. Now, we were talking about data. Where is this data stored? We can use traditional database systems, right? Now, consider an organization. Okay, it will be having multiple heterogeneous databases. Okay. Now, if suppose I want to mine some knowledge from that, I have to pose a query to multiple databases, right? It's not a single database. It will be multiple heterogeneous databases. So with the help of a metadata dictionary, the queries has to be converted to different query which is applicable for individual heterogeneous sites. Okay. Finally, these queries has to be mapped and the results will be generated. Once the results are generated, it has to be integrated. I'll tell you an example. Suppose, take the example of college itself. You will be having multiple databases for storing staff information, student information, etc. Assume that you are storing student information batch-wise in separate databases. Okay. Now, if suppose I want to analyze the result, okay, and see the effect of result and curriculum on the placements, okay, I have to do a comparative study, how a curriculum can influence the placement. I have to do a comparative study for the past 10 years. What can I do? If I have multiple databases, I have to first create a query. That query has to be converted to different queries aimed at different databases. I have to throw to different databases, get the results individually, combine and integrate it. This task becomes very tedious. Okay. Now, what is the alternative for this approach? The information from multiple heterogeneous sources can be integrated and stored for direct querying and analysis. The data can be copied, it can be pre-processed, it can be integrated and summarized and stored in a single data store. Okay, such a data store is called data warehouse. So data warehouse is nothing but a single data store where data will be present from multiple databases. From multiple databases, you will be taking the data, you will be doing some pre-processing on the data, you will be combining it and storing it in a summarized form. That is called as data warehouse. Okay. So, we welcome you to the video lecture series of data warehousing and data mining. I hope I have set a context for data warehouse and data mining. So once again, welcome you all to the video lecture series of data warehousing and data mining. Let's have a brief overview about the course and the outcomes. So basically here, module 1 and module 2 covers data warehousing concepts. You will be able to describe what is data warehousing. Once you complete this module 1 and module 2, you will be able to describe completely what is data warehousing. You will be able to understand the architecture of a data warehouse. You will be able to implement a data warehouse as well. Module 3 deals with data mining, introductory part of it. What data is mined, what patterns are extracted, all those things will be dealt in the third module. Module 4 and module 5 will be covering data mining tasks like association rule mining and classification, cluster analysis and outlier detection. Association rule mining and classification will be dealt in module 4. Cluster analysis and outlier detection will be dealt in module 5. All these are data mining tasks. How do you perform data mining? And finally, in module 5, we will be dealing with data mining trends, the current trends in data mining. With this brief course overview, let us go to module 1, data warehousing. So what is a data warehouse? So data warehouse is defined in many different ways. A formal definition is put over here. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. Okay. Now, the terms subject oriented, integrated, time variant, and non-volatile will be seeing in detail. Okay. So basically, data warehouse is a collection of data which helps the management to do decision making. Okay. So we can tell it as a decision support database, and it is maintained separately from the operational databases. As I told earlier, there will be multiple heterogeneous operational databases. From there, we will be taking the data, integrating it, and putting it in the data warehouse. And the point to be noted is that the data warehouse will be maintained separately from the organization's operational databases. The data warehouses support information processing by providing a solid platform of consolidated historical data for analysis. As I told, if suppose a college is having the student information stored in separate databases for the past 10 years, okay, it will be stored in separate databases. From those databases, I can take the relevant information which I need for my decision making process. I can take that data and put it in a single data store. And such a data store is called as a data warehouse. And it helps in the decision making process. The process of constructing and using the data warehouses is called as data warehousing. Okay. Now we'll see in detail the definition of data warehouse. I had told that data warehouse is subject oriented. What do you mean by that? Subject oriented. So usually the data warehouses will be organized around major subjects. What are the examples of subjects? It can be a customer. It can be a product. It can be a student. It can be a faculty. It can be another entity like the library. So basically, the data warehouse will be organized around major subjects. Okay, it is subject oriented. It will be more focusing on the modeling and analysis of data for decision makers, not on daily operations or transaction processing. The traditional databases or the operational databases will be focusing on day-to-day operations, day-to-day transactions. But the data warehouses is mainly used for modeling and analysis of data for important decision making. Okay, I had told the example, one important example I had told, if I have to understand what is the impact of different curriculum on placements, okay, I can create a data warehouse which contain relevant data applicable only to students, okay, only for my particular subject. From the data warehouse, I can analyze, make an analysis and come at a decision or arrive at a conclusion, right? So data warehouse provide a simple and concise view around particular subject issues by excluding data that are not useful in the decision support process. You will be excluding the data which are not useful. You will be taking only the meaningful data which is needed for that particular context. Okay, so it will be modeled around a specific subject such as a customer, a student, a faculty, an item, anything like that. Okay. Now the second term which I coined was data warehouse is integrated. Okay, from the word itself you can understand integrated means something which is combined. Okay, so it is constructed by integrating multiple heterogeneous data sources. Not only database, it can be files, it can be online transaction records. From all these data sources, you will be taking important data which is relevant to your decision making process and integrating it and putting it in the data warehouse. So before constructing the data warehouse, you have to do the process of data cleaning and data integration. Why you are doing data cleaning and data integration? To ensure consistency. Okay, take the example of naming convention. Maybe in one database, I would have given the name as percentage for marks. Okay, now in the other database, I would have mentioned grade for marks. Okay, When I'm constructing the data warehouse, I have to integrate the data from all these databases. There should not be conflict in the naming convention. I have to follow a uniform format over there, right? Similarly, take 5 years before, we were storing marks as percentages. Now we are using CGPA system. So when we are putting in the data warehouse, it should be a uniform format. Either we have to convert CGPA to percentage, or we have to convert percentage to CGPA. So all those pre-processing needs to be done before the data is put into the data warehouse. Okay. Now when the data is moved to the warehouse, it is converted. So I hope you understood what do you mean by integrated. The data warehouse is built by integrating multiple heterogeneous data sources. From all these data sources, we will be taking the data. We will be doing some data pre-processing to maintain an uniform format, okay, and building the data warehouse, okay. Now the third term, data warehouse is time variant. What do you mean by that? Time variant. So the time horizon for the data warehouse is significantly longer than that of the operational systems. In the operational database, always you will be storing current data. Whereas in the data warehouse, you will be providing information from a historical perspective. You will be storing data for the past 10 years, for the past 15 years. So from a historical perspective, you will be putting the data in the data warehouse. Whereas in the operational database, you will always be keeping current data, because we will be using for day-to-day operations, day-to-day transactions, right? So data warehouse will be having information from a historical perspective. That's why we tell that data warehouse is time variant. Okay. Now the last thing is data warehouse is non-volatile. What do you mean by non-volatile? Volatile means changing. Non-volatile means not changing. Okay. So data warehouse is a physically separate store of data transformed from the operational environment. This I had already told. In the operational environment, you will be having multiple operational databases, but data warehouse will be stored separately from all this. Okay. And the information in the data warehouse is non-volatile. The update to the data does not occur in the data warehouse. Okay. The operational databases, we will be doing frequent update operations. The day-to-day transactions will be performed. Day-to-day operations will be performed. Additions, deletions, etc. will be performed more frequently in the operational databases. But in case of data warehouse, we will be loading the data to the data warehouse and just accessing the data from the data warehouse. Basically, we will be mostly performing read-only operations on the data warehouse. You will load the data to the data warehouse and then you will be accessing the data from the data warehouse. So these are the features of the data warehouse. So what is a data warehouse? Data warehouse is a subject-oriented, integrated, time variant and non-volatile collection of data in support of management's decision-making process. Okay. So in today's session, what all we have seen? We have seen the difference between data, information and knowledge. What is the difference? Data is a simple set of symbols and characters or observations, right? Now, when I attach context to data, it becomes information. Now, what about knowledge? When I further process the information, link and store it, it becomes knowledge. Okay. And we also saw that so much of data is being generated, but it's hard to find meaningful information from it. There comes the necessity of data mining. So what is data mining? Knowledge discovery from data. That is data mining. Okay. Then we saw that data, as per traditional database approach, data will be stored in multiple heterogeneous databases. So it is difficult to combine. If I have to make a comparative study, to make a important decision, if I have to do a comparative study, it's a tedious task to get data from all these sources, integrate it and come to a conclusion. So an alternative approach what we adopt is building a data warehouse. So what is a data warehouse? Data warehouse is basically a decision support database. It is maintained separately from the organization's operational databases. The operational databases will be used for day-to-day operations, whereas our data warehouse will be used for management's decision-making process. Okay, so the data warehouse will be subject-oriented, integrated, time-variant, and non-volatile. Subject-oriented means what? It is built around a particular subject. Okay, like a customer, like a student. Okay, so these are examples of subjects. Data warehouse is built around a particular subject. That's why we tell it is subject oriented. Now, the data in the data warehouse will be taken from multiple heterogeneous databases and combined and kept in a summarized form. So that is called as integration. So when you do integration, you will have to perform some data pre-processing to ensure consistency. I had told one classical example regarding naming conventions, right? So in some of the databases, we'll be using different names. For example, for storing the roll number of students, recently we will be using the term as USN. Earlier, we might have used the term as register number. So there will be conflict in the naming convention. So in order to avoid that, you will be doing some data pre-processing, right? Now, another example is attribute conversion. Okay, so marks, earlier days we were using percentages. Now we are using CGPA. So when you keep the data in the data warehouse, there should be a uniform format being followed. To follow that uniform format, you have to do some data pre-processing. Okay, so data warehouse is subject oriented, integrated. Then what is it? Time variant. Time variant means always the data will be stored from a historical perspective. In the data warehouse, you will be storing the data from a historical perspective. You will not be having the current data. Instead, you will be having the data for the past 5 to 10 years. The current updations are done in the operational databases. Now, the data warehouse is also non-volatile. What do you mean by non-volatile? As I told, it doesn't keep changing frequently. In case of operational databases, you will keep updating the database very frequently. Okay, hour by hour, minute by minute, there can be updations in the operational databases. But in the data warehouse, the updations are very rare. You will just load the data. At intervals, you may refresh the data and you will access the data. That's it. Okay. Now the process of constructing the data warehouse and using it is called as data warehouse. Okay. Now in the next session, we'll be seeing the difference between data warehouse and operational databases in detail. Also, we'll be seeing about the data warehouse architecture. Thank you one and all.